Assalamualaikum and a very good day to Dr. Nazri. My name is Muhammad Aiman bin PATIHE, and I am going to present to you about field effect transistor, and that is FET. What is field effect transistor? The field effect transistor, FET, is a type of transistor that uses an electric field to control the flow of current in a semiconductor. FETs are devices with three terminals: source, gate, and drain. FETs are also known as unipolar transistors since they involve a single carrier type operation. Move on to types of FET. There are two types of FET. One is junction field effect transistor, and the second one is metal oxide semiconductor field effect transistor, and that is JFET and MOSFET. What is junction field effect transistor? The junction field effect transistor has no PN junctions, but instead has a narrow piece of high resistivity semiconductor material forming a channel of either N-type or P-type silicon for the majority carriers to flow through with two ohmic electrical connection at either and commonly called the drain and the source respectively. And moving to MOSFET. MOSFET is a voltage control field effect transistor that differs from a JFET in that it has a metal oxide gate electrode, which is electrically insulated from the main semiconductor N channel or P channel by a very thin layer of insulating material, usually silicon dioxide, commonly known as glass. These are the advantage and disadvantage of FET. The advantage is FETs are voltage sensitive device with high input impedance. Since this input impedance is considerably higher than that of BJTs, FETs are preferred over BJTs for use as the input stage to multi-stage amplifier. Next one is one class of FETs, and that is JFETs, generate lower noise than BJTs. And the third one is FETs are more temperature stable than BJTs. Move on to disadvantages. FETs amplifiers usually exhibit poor frequency response because of high input capacitance. Next one is some type of FET exhibit poor linearity. FETs can be damaged in handling due to static electricity. One of the most widely used electronic device, particularly in digital integrated circuits, is the metal insulator semiconductor transistor, and that is MOSFET. In this device, the channel current is controlled by a voltage applied at a gate electrode that is isolated from the channel by an insulator. These are the process of MOSFET. The end source and drain regions are diffused or implanted into a relatively lightly doped P-type substrate, and a thin oxide layer separates the conducting gate from the Si surfaces. No current flow from drain to source without conducting N channel between them. This can be understood by clearly looking at the band diagram of MOSFET in equilibrium along channel. The Fermi level is flat in equilibrium. The conduction band is close to the Fermi level in the end source or drain, while the valence band is closer to the Fermi level in the P-type material. Hence, there is potential barrier for an electron to go from the source to the drain, corresponding to the built-in potential of the back-to-back PN junction between the source and drain. When a positive voltage is applied to the gate relative to the substrate, which is connected to the source, in this case, positive charges are deposited on the gate metal. In response, negative charges are induced in the underlying silicon by the formation of a depletion region and a thin surface region containing mobile electrons. This induced electrons from the channel of the FET and allow current to flow from drain to source. Moving on to MOSFET. The MOSFET is a high performance form of field effect transistor that is used mainly for exacting microwave application, both as low noise signal amplifier and in higher power RF circuits. The abbreviation MOSFET stands for metal semiconductor field effect transistor, and the most widely used form is the GaAsFET, fabricated using the 3IV semiconductor material gallium arsenide. There are two structures of MOSFET, and they are non-self-aligned source and drain and self-aligned source and drain. For non-self-aligned source and drain, the gate is placed on a section of the channel. The gate contact does not cover the whole of the length of the channel. This arises because the source and drain contacts are normally formed before the gate. For the self-aligned source and drain, this form of structure reduces the length of the channel, and the gate contact covers the whole length. This can be done because the gate is formed first, but in order that the annealing process required after the formation of the source and drain areas by ion implantation. The gate contact must be able to withstand the high temperatures, and this results in the use of a limited number of material being suitable. These are the process of MOSFET. One is enhancement mode MOSFET. In an enhancement mode MOSFET, the depletion region is wide enough to pinch off the channel without applied voltage. Therefore, the enhancement mode MOSFET is naturally off. When a positive voltage is applied within the gate and source, the depletion region shrinks and the channel becomes conductive. Unfortunately, a positive gate to source voltage puts the Schottky diode in forward bias, where a large current can flow. Depletion. The second one is the depletion mode MOSFET. If the depletion region does not extend all the way to the p-type substrate, the MOSFET is a depletion mode MOSFET. A depletion mode MOSFET is conductive or on when no gate to source voltage is applied, and it is turned off upon the application of a negative gate to source voltage, which increases the width of depletion region such that it pinches off the channel. And that is all from me. Thank you very much.